Hi, welcome to my presentation on hydrogen fuel cell for my certificate in sustainability. My name is Jashanbir Singh Khattra, and I am a final year chemical engineering student. So in modern society, humans are heavily reliant on energy to go on with their day-to-day lives. And from heating our homes to traveling to jobs, we rely heavily on burning fossil fuels to get us throughout the day. And although burning fossil fuels releases energy, it also releases greenhouse gases, which are harmful to our planet. And the increase of these uh, released greenhouse gases is trapping more and more heat from the sun and the Earth's atmosphere, and it's raising our global temperature. And with this raising temperature, global warming poses a serious health and environmental threats as it's melting down the ice sheets in the Antarctic. And the increased temperature is also causing extreme weather conditions, such as frequent floods, extreme storms, heavy snowfalls, and even longer droughts. And among other impacts of climate change, it can also negatively impact our habitat by creating changes in average temperatures and precipitation that may make it difficult for plants and animals to survive in the future. A leading source of these greenhouse gases emissions is the transportation industry, and it accounts for about 25% of CO2 global emissions. And further breaking it down, it can be seen that 75% of these 25% emissions is from cars and trucks. And if humans don't alter their practices quickly, we'll make our planet uninhabitable in the future. And one way to slow down these effects is by transitioning to renewable energy systems. Renewable energy comes from sources that can be naturally replenished at a rate that is equal or greater than their use. An example is biomass energy, which is also which refers to plants such as corn, sugarcane, and others that are grown for the use as biofuel. Byproducts of the forest industry, including wood chips, sawdust, and bark, are also used as biomass. Biomass material is derived from living organisms, both plants and animals. Renewable energy also comes from continuing natural energy flows, such as solar radiation, wind, and even flowing water and geothermal sources. Geothermal energy is accessible heat from the Earth's interior and is used to generate electricity to supply heat. And through this presentation, I will be exploring one such emerging renewable energy system called hydrogen fuel cells. So a hydrogen fuel cell is basically an electrochemical power generator that combines hydrogen and oxygen to produce electricity and with water and heat as byproducts. And hydrogen fuel cells technology offers the advantages of clean and reliable alternate energy source. And fuel cells can be used in wide range of applications such as transportation, industrial, commercial, and even residential buildings, long-term energy storage for the grid. An example of its current application is the Edmonton Hydrogen Bus Project. So currently there's two hydrogen buses that are running on hydrogen fuel cells, and they're shared between City of Edmonton and Strathcona County. The project costed about $9.8 million, and which 4.6 million was provided as funding. The hydrogen being used in this buses is being supplied by Alberta's industries, and it's mainly going to be blue hydrogen. And the heat being generated in the process will be used to heat up the buses during winter. Another example is the BC Transit. They bought 20 buses back in 2010, but the Transit Authority sold them off because of high maintenance cost in 2014. And it costed BC Transit about $90 million. And I'll be exploring more of this in the future slides. So operating principles of a hydrogen fuel cells. Fuel cell consists of two electrodes, a negative electrode, anode, and a positive electrode, cathode, which is sandwiched together around an electrolyte. Hydrogen is fed to the anode and oxygen is fed to the cathode. A catalyst at the anode separates the hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through the external circuit, creating a flow of electricity, and the protons migrate through the electrolyte to the cathode, where they unite with the oxygen and electrons to produce water and heat. A electrolyte or a PEM plays a key role, and it only permits the appropriate ions to pass between the anode and cathode. If free electrons or the other substances could travel through the electrolyte, they would disrupt the chemical reaction. As long as a fuel cell is supplied with hydrogen and oxygen, it will generate electricity. And even better, since they create electricity chemically rather than by combustion, therefore these fuel cells are more efficient in extracting energy from the fuel. And waste heat from cells can be harnessed by boosting the system's efficiency even further. Hydrogen source. So where does all the hydrogen for these fuel cells come from? There are many ways to produce hydrogen, but for this purpose of this presentation, I will be focusing on hydrogen produced from low or zero carbon energy sources. So green hydrogen. Green hydrogen is produced from electrolysis of water. So electricity from these renewable sources like hydropower, wind, and solar. And it's zero carbon emissions as well. And you'll need about 99% pure water, as other contaminants can affect the process of producing green hydrogen. Additionally, it's also very expensive to operate currently. So blue hydrogen. Blue hydrogen is extracted from natural gas using steam methane reforming, or it's also extracted from fossil fuels using gasification. And the CO2 produced in the process is usually stored underground and in salt caverns. So you'd ask, what if this technology sounds so amazing that it's efficient and only produces water vapor heat? Why has it not been implemented already? So there are some problems associated with it. Most fuel cell systems are fueled with pure hydrogen gas, which is stored on board as a compressed gas. Since hydrogen gas has a low energy density, it's very difficult to store enough hydrogen to generate the same amount of power as conventional fuels such as gasoline. This is a significant problem for fuel cell vehicles, which need to have a driving range of around 300 to 400 miles between each refueling to be competitive against gasoline vehicles. In addition to onboard storage problems, our current infrastructure for liquid fuel to consumers cannot be used for gaseous hydrogen. And new facilities and delivery systems must be built, which will require significant time and resources, and costs for large-scale development will be substantial. And high-pressure tanks and other technologies are being developed to allow for large amounts of hydrogen to be stored in small enough for passengers, cars, and trucks. So another problem is the cost. So blue hydrogen costs around $1.50 per kilogram, and green hydrogen costs up to $5 per kilogram. And retail costs for hydrogen at refueling stations are between $12 to $17 per kilogram. To put this into perspective, 1 kilogram is about 1 gallon of gasoline equivalent. And 1 gallon price for premium gasoline today was approximately $4. And hydrogen needs to be priced between $5 to $6. And currently the hydrogen is being retailed at around $16.5 per kg. Another big problem is the refueling infrastructure. Currently in Canada, there's only 3 hydrogen refueling stations situated in Vancouver, and one's situated in Victoria, and one's situated in Quebec City. There is around 54 situated in California, and Additionally, to set up a refueling station, it can cost up to $2 million for just one pump. So my conclusion, fuel cells have several benefits over conventional combustion-based technologies currently used in many power plants and vehicles. Fuel cells can operate at higher efficiencies than combustion engines, as they can convert chemical energy directly to electrical energy with efficiencies exceeding 60%. The best combustion engine built as of today has an efficiency around 25%. Fuel cells also have lower or zero emissions compared to combustion engines. And hydrogen fuel cells only emit water and addressing critical climate change as there are no carbon dioxide emissions. There are also no air pollutants that create smog and cause health problems at the point of operation. Fuel cells are also quiet during operation as they have fewer moving parts, and they also lack the high charging time problem that electric vehicles have. It just takes about 5 minutes or so to refuel them for like another 300 to 400 miles. And with the technology evolving rapidly, hydrogen fuel cells show promising results for revolutionizing the transportation industry.